So this is a Module 7 Investigation 4 and using sine and cosine function to track the circular motion. So note that consider all the values of the data in this investigation to be expressed in radian. Okay, so in this one, I'm going to do number 3 and 6. Okay, so let's go to number 3. So we need to remember that the sine and cosine functions are defined as the x equal to cosine theta and the y equal to sine theta because this is a unit circle. Okay, so x is actually the cosine theta here, but this is r, but in here r is a 1, so you can just say x by itself. Given that the x and y the point on the unit circle means the highest you can get is 1 and the lowest you can get is -1. And the theta is in the measure of the angle with the subtends the arc between the 1.0 and the x and y. So you go around anywhere. So this is the initial side, and then you can end up to any of the places here. Okay, so but there's already a given place. Alright, so that's what we're gonna do here. So A, use a unit circle to generate a graph of the y equal to sine theta, where the theta is the measures of the angle subtending the arc between the 1 and 0 to any of the order pair on the circle. Label value on your axis and A points on your graph using the given points on the circle. So we're gonna put down as horizontal axis the theta, but which in radian. And then on the vertical, it's going to be the sine theta. So first of all, we have to find the theta first, okay? So in order to find the theta, since we got the everything, right? So I'm going to use this formula here. So formula is going to be the S equal to R theta, which is arc. So, well, is it a better one or? No, let's not use this one. Okay, let's use the theta. Theta is gonna be the sine inverse of y over r. Okay, I think that's a better. So if you use this is a 0, no matter what, right? And then for the second one on here, so let's get all the data. Okay, so on this point, so what's the angle from the vertical, the horizontal axis, right? So theta is sine inverse of y is a 0.71. And then we know the r, which is 1, right? R is this one. The length of this is actually the radius of the circle, which is 1, right? So if you use the calculator, you get the 0.79. And then 0.1 place, of course, it is a pi over 2, right? But pi over 2, which is, so you can do the same thing too. So theta is going to be sine inverse of y is a 1 over 1, isn't it? So it's a sine inverse of 1. So which is come out as pi over 2. But the pi over 2, I want to make that as a decimal. So pi divided by 2 is 1.57. Now, another point is right here. Okay, we are looking for all A points. So we have 2 points so far. Okay, so this point is theta is going to be the sine inverse of 0.14 over 1, right? Which is come out as 3. And then also the negative 1.0, so theta is going to be a pi, which is 3.14. For this point, theta is sine inverse of, we only need a y because r is a 1, so negative 0.61. And then we should get the angles of 3.80. For the 0, -1, theta is actually the sine inverse of -1, which come out as a 4.71. Okay. And then for the last point, which is theta is going to be sine inverse of negative 0.93, and then we can use as a 5.09, which is angle must be the increasing, okay? Because for the up to here is this is angle, up to this point is this is angle, and this is the angle, okay? And up to here, and this is going to be an angle. and then all the way to this angle, and then terminus is now here, so and then all the way to come here. So we already found all the angle. Now when you go back to your original place, then theta also become 2 pi, which is 6.28, isn't it? So 0 and 2 pi is actually as a same location for the circular motion, okay? So what I do is, since I use the angle as a number, so I want to do the every 2 is a 1. So I want to put that as a 1, 2, 3, 4, 5, and 6, and 7. So you repeat it again. 5, 6, 7. And then as a vertical distance, it only go up to the 1, right? So I want to say 0 0.1, 0 0.2, 0 0.4, 5, 6, 7, 8, and then 1.0. Down here, negative 0 0.2, negative 0 0.4, negative 0 0.6, negative 0 0.8, and negative 1.0. So when the 0 degree was the y value, you only use the y, and this is y over r, right? But the order pair is actually the theta and the y, okay? That's what you need. Theta and y, because this is a y, isn't it? So theta and y. So theta for the 0 is a 0, and then the y is a 0, isn't it? So it's starting from the 0, 0. Let me use another color here. And then the first point after that is going to be theta is 0 0.79. Talking about this. And then y is 0 0.71. So 0 0.79, so more than 0 0.5. And then 0 0.71, so about here. And then up to the pi over 2, which is 1.57, is actually go up to the 1. So, okay, all the way up to 1. And then to go to the second quadrant, so theta is now the 3, which is going to be 0 0.14. About here. And then to go 3.14 becomes the 0. And then next one is angles is a 3.80 is a negative 0.61. And then next one is angle is 4.71, and then becomes a negative 1. And then the 5.09 is the negative 9.2, very close to here. And then go back to the 6.28, it's a 0, right? And then if you connected it, it's gonna give us a the graph that you want, okay? You just need to connect those points nicely as a curve. And then what happened is, it's gonna repeat it, okay? Alright, so now, B. What is the domain of the sine function, or what is the range of the sine function? So domain is an Aubrey number. And then the range is, where's the range? Okay, graph is all the way to go up 1 and down to negative 1. So from the negative 1 and 1. And then what is the concavity of the sine function on the interval of pi over 2 to pi, which is from here to here. Which is, we have to check from the pi over 2, which is 1.57. So 1.57 is about here, right? To up to the pi here. So it's actually the concave down, right? So this is a concave down, so we can say negative concavity, which is we can call the concave down. Okay, so D, using the unit circle above the generate the graph of, now we're going to make the cosine function graph. So since the data, and we put the cosine theta, which is x, okay? And then the same way. So I'm going to do 1, 2, 3, 4, 5, 6, and 7. And then actually the plane is broken, so I just try to connect it, okay? So I have 0 0.2, 4, 6, 8, 10. On the bottom here, negative 0 0.2, negative 0 0.4, negative 0 0.6, negative 0 0.8, and negative 1.0, okay? So now we are looking at the x coordinates here, okay? So x coordinates from the 0 degree is actually the 1, isn't it? So you are using the, in here, as a theta and x value, okay? So you're gonna get the 0 and 1. And then the next one is 0 0.79 is going to be negative 0 0.71. So same as the first one, so 0 0.79, 0 0.71. And then the pi over 2, which is 1.57, it's going to be the 0, isn't it? Right here. And then go to the third 3 is going to be now the negative 0 0.99. Okay, so 3 is very down here, right? It's almost a negative 1, right? Is it 3 is right here? Or this one? Okay, this one should be this one. Okay, so I shouldn't use this one. So. And then next one is 3.14 is going to be a 0. No, it's going to be a negative 1 way. So 3.14. Okay. Oh, sorry about that. Yeah, it's hard. Okay, so oh, no. That's not right. Okay. So I need to get negative 3 to down here for the negative, very close to 0. Okay, and the next one is here for the pi of the negative 1. And the next one is 3.80. It's going to be the negative 7.9. Negative 7.9 is close to here. And then you get to the 4.71 becomes the 0. And then next one is a 5.09. It is a positive 3.8. Okay. And then you got go back to the 6.28 becomes the 1. Okay, so you get this. It's connected in. Okay, all the way to here. Go back. Yeah, here. So yeah, ignore this part, okay? Yeah, this shouldn't be here. It has to be connected. So what do you see that as a E that the S data varies from the 0 to pi over 2? So for this one, we are looking for only this one, okay? So 0 to pi over 2, which is we only looking at the from here to here. So what's happening? It's still concave down too, isn't it? So it's a negative concavity. Negative concavity, which means it's concave down. Alright, now we're looking up the number 6. So in number 6, the construct the angles on the unit circle with this radian measures, okay? So what we need is, first of all, when the 3 o'clock position is a 0 radian, and then this is pi over 2 place as a radian, and this is a pi, and 3 pi over 2, right? And then go back to the 2 pi, okay? So what I needed is when I actually construct the pi over 6, so pi over 6 means you need the 6 of the pi over 6 can fit it into the 0 to pi, isn't it? This is a pi, isn't it? So I'm going to make the 6 pieces, okay? So about that. Okay, so 1 and 2. equal pieces, okay? So the first place I can say pi over 6 and 2 pi over 6, which is pi over 2 same as 3 pi over 6. 4 pi over 6, which is same as 2 pi over 3. And then 5 pi over 6. And then same thing here too. I need to go to 6. So I'm going to make another 3 pieces here. So pi is going to be 6 pi over 6. Next one is a 7 pi over 6. 8 pi over 6, which is the same as 4 pi over 3. And then same pieces. It's going to be you're going to 9 pi over 6, which is 3 pi over 2. And 10 pi over 6, which is 5 pi over 3. And then 11 pi over 6. And then this is going to be the 12 pi over 6, which is a 2 pi, isn't it? Yeah, so we just construct it. And B, use your calculator, determine the coordinate of the corresponding the angle measure of the pi over 2. So if you actually put it out here, right, we are looking for this angle. So pretty easy, right? What do you do? So what will be the angle with the pi over 2 radian and describe? So we are looking for coordinates, okay? So what is that point? What is that point? Of course, it's going to be x and y, isn't it? But if you're looking at the polar coordinates, we are using instead of the x, we are using the theta. As the polar, the x is the same as the sine theta. And then why am I thinking? X is same as cosine theta, and the y same as the sine theta. So that's what you needed. Okay, so in order pair on the pi over 6, it's going to be the cosine pi over 6, and then sine pi over 6. And then if you're using a calculator, it'll say 0.866, and then 0.5. Now you can do that too, but this time do not use a calculator. So in order to say that do not use a calculator, we need to create the right triangle here. But we need to know about pi over 6 in the degree, right? You know that, right? So this is actually the same as a 30 degree. But the 30 degree actually they make us a very nice right triangle. So since they are looking for the 5 pi over 6, and then 7 pi over 6, and then the 11 pi over 6, you know? So it all creates the right triangle, okay? Right, which means between the horizontal axis to the terminal sides is the same angle here. Don't you see? Right, so in order to find those thing, it's about the sign change. So, but there's a very important ratios in that triangle. So important ratio is if the shortest side is 1. Forget about the unit circle, okay? So for the ratio, okay? So it's a 1, and then the hypotenuse are always a twice of this. And then for the other side, using the Pythagorean theorem, which is a squared plus b squared equals to c squared, it comes out as a radical 3. Okay? So you can just convert it here as a ratio. So since this is a 1, so yeah, so we convert to the way that we have here, right? So that is a common ratio for the 30 degree and the 60 degree. Okay, so the ratio between here this time we have here, it is actually, this is about the 0.5 because this is a 1, okay? So twice, isn't it? And then this is about the 0.866, okay? But order pairs are by x and y, so only do the x and y, right? But so in the 5 pi over 6, so we have theta equal to 5 pi over 6, right? Which is the same as cosine 5 pi over 6, comma, sine 5 pi over 6, which is going to be the cosine in the second quadrant, which is 5 pi over 6 there lies, is going to be the negative 0.866, comma to the, but the y is still positive, right? So 0.5. for the theta equal to the 11 pi over 7 pi over 6, right? Which is cosine 7 pi over 6, sine 7 pi over 6. But that's in the third quadrant, so both x and y's are negative. And the fourth quadrant, which is theta is 11 pi over 6, so you got cosine 11 pi over 6, sine 11 pi over 6. It's going to be, x is now become positive, but y's are still negative. Okay. Yeah, so you can find this as a formula. Alright, that'd be all for this investigation. Thank you for listening.